All right, number 13. It is false that some pet lovers are people who think that animals are mere machines. Therefore, it is false that all pet lovers are people who think that animals are mere machines. All right, so first thing I have to do is identify the conclusion and the premise. Fortunately, we've got an indicator word here, so I know that this is my conclusion, this is my premise. The next thing for me to do is to identify my subject and predicate terms. I can see that my subject term here is pet lovers, so I'm just going to go ahead and use P to represent pet lovers. And then the predicate term is a bit longer. People who think that animals are mere machines. Okay, so people who think that animals are mere machines, I'm going to use M for that. So that stands for people who think animals are mere machines. Or put down, or however you'd pronounce that. All right, so the next thing I have to do is I have to represent this argument symbolically. It's going to always make things much easier for me to do. The difficulty here is that I have this phrase, it is false that, on both the premise and the conclusion, and that can make Venn diagramming really difficult. Okay, so what I want to do is I want to get rid of that phrase, it is false that, so I have some sentences that are true to diagram. So I can do that by using either the modern or the traditional square of opposition, because on that square is the rule of contradiction. And it tells me that if I have an I claim, like my premise, some pet lovers are people who think that animals are mere machines, and that statement is false, then by the rule of contradiction, the corresponding E claim would have to be true. So I'm going to take that I claim and turn it, that's false, and turn it into a true E claim, because I can diagram true sentences much easier than I can false ones. So I'm going to do that same thing here on my conclusion. I'm being given an A claim as my conclusion, and I'm being told it's false. So if I locate A claims on the squares of opposition and trace that line of contradiction diagonally downward, I come to an O claim that would have to be true if its corresponding A claim is false. So now I have my argument and I can Venn diagram it. So I'm going to draw my two containers here. I'm going to get in the habit of putting numbers in there. And then this is going to be the container of pet lovers. And then this is going to be the container of people who think that animals are mere machines. So now I'm going to diagram in the premise. I want to know what the premise looks like when it's true. So if no P or M, I'd have to turn out the lights in this middle area here, because that's where any P's would be that are also M's. Now I'm not going to diagram the conclusion. I never go anywhere near the conclusion when I have a pen in my hand. And I look to see, do I see the conclusion show up in this Venn diagram? I'm showing what it looks like when the premise is true. And I'm assuming the premise is true because I want to know if the argument is valid. So if it is valid, then I will see the conclusion show up in this Venn diagram when I'm showing that the premise is true. Now, if this conclusion were here, I'd see an X somewhere in 1, because the conclusion says that some P are not M. So in order for there to be any P's that are not M's at this point, they would have to be here in 1, because that's the only place left where any P's can be. But I don't see an X there. That means I don't see the conclusion there. And that means this argument is invalid from a Boolean perspective. And that makes sense, right? Because we have a universal premise and a particular conclusion, and those are never valid from the Boolean perspective. That's always going to be an existential fallacy. But just because it's not valid from the Boolean perspective doesn't mean it's not valid from the Aristotelian perspective. So I can look again at this Venn diagram with my Aristotelian goggles on, and what I'm looking for is not the conclusion. What I'm looking for is any area of either the P circle or the M circle that's the only area left where any P's or any M's could be. When I look at the P circle, I see that any P's that exist have to be here in 1. So if they're all there, there has to be at least 1 there, provided P refers to something that actually exists. Now, if you wanted to, you could put an X with a circle in it over here, because 3 is the only area where any M's could be. So now the question is this: after I've put my X with a circle in it, do you see the conclusion? Yes, I do. So now the question is this: do P's exist? In other words, are pet lovers a real thing? And thankfully, yes, there are. So this argument, yes, they are. So this argument is valid from the Aristotelian standpoint, and the condition for validity has been met.